Lance Armstrong is considered one of the greatest athletes of our time. Despite great adversity, he's won 7 Tour de France races and earned superhuman status in the minds of many. The average cyclist can ride at about 16 miles per hour, but Lance can travel 32 miles per hour or more. That measurement, miles per hour, is an example of a rate. A rate is a ratio of changes in 2 different quantities. It can be expressed as the change in one quantity for a unit change in the other. Miles per hour is a rate because it's one quantity, the number of miles Lance travels, changing in relationship to another quantity, time. So, distance and time are 2 quantities of the rate called speed. Here's another rate. When Lance trains, doctors measure his heart rate. It's considered a rate because it's the ratio of 2 quantities, the number of heartbeats and an amount of time, usually in minutes. We can represent Lance's heart rate on this graph. The y-axis represents the number of times his heart beats, and the x-axis represents the passage of time. The slope on the graph is the rate that his heart is beating, so the rate is beats per minute. Displayed on the graph, it's easy to see that it has 2 quantities, changing together to determine the rate. Let's follow Lance and see how he meets his need for speed. The Tour de France is over 1,500 miles long, requires its competitors to be in tip-top shape, and ultimately rewards the fastest cyclists. So, the event, though about strategy and stamina, boils down to speed. Speed is a rate that can be calculated using any distance measurement and any time measurement. It's commonly expressed in miles per hour or kilometers per hour for vehicles, and in feet per second or meters per second for many other objects. Regardless of the unit, if you divide the distance something travels by the time it takes to travel it, you'll arrive at the speed of the object. For example, if Lance travels 34.1 miles in 1 hour and 6 minutes, we can figure out his rate in miles per hour. That rate is his average speed over the distance. Let's use the formula. Distance, 34.1 miles, over time, 1 hour and 6 minutes, or 1.1 hours, equals speed. Divide 34.1 by 1.1. That's 31. Lance traveled 31 miles per hour. For a car or an airplane, it's not so fast, but for a bicycle, that's fast. Lance's heartbeat over time has a rate, his heart rate. It expresses how many times his heart beats each minute, or beats per minute. The uphill distance he bikes, over the time it takes him to bike it, is also a rate, his speed. That is usually expressed in miles per hour or kilometers per hour. Notice how both of these rates involve the passage of time? The term rate is often used to refer to something happening over time. But the change in any quantity with respect to another can be considered a rate. Lance may not need any gasoline while traveling by bike, but his trainer does if he wants to monitor and keep up with Lance. The miles his trainer travels for each gallon of fuel his car consumes is also a rate. The miles traveled for each gallon used is miles per gallon, typically referred to as mileage. Fuel also has a rate associated with its sale. It's the amount you pay for each gallon of gasoline. So, the total dollars paid divided by gallons is dollars per gallon, a per gallon rate of sale. Fuel for Lance is food. An average bike racer consumes about 5,900 calories per day. That's also a rate. The number of calories used over the course of a day. That involves time.
He needs to be taken in about 30 to 60 grams of carbohydrate every hour.
Food, like automobile fuel, is also sold at a particular price for a given amount. That's a rate too, a rate of sale per amount. So no matter what you're considering, if you can measure its change in respect to a change in a second quantity, it's a rate. Different modes of transportation have different capacities and capabilities. If you travel by bike and are Lance Armstrong, your top average speed might be over 30 miles an hour, which is slower than most modes of transportation. But hey, you don't need gasoline for fuel. But if you do, like for cars, trucks, buses, and planes, understanding rates will most definitely help in your travels. For instance, it's useful to know how many miles per gallon your car travels so you know how often you need to stop for gas. Here's one example of how you can use a rate. If your car holds 20 gallons of gas and gets mileage of 16 miles per gallon, how many miles can you travel before you need to refuel? Here's how to figure it out. Multiply 16 miles per gallon by the 20 total gallons your gas tank holds. 16 miles per gallon times 20 gallons equals 320 miles. But if you travel more than 320 miles without refueling, you'll run out of gas. Now notice, a rate is a change in one quantity with a change in another. We can talk about how many miles our car travels per gallon of gasoline, its mileage rate. Or we can talk about how many gallons the car uses for each mile it travels. That's also a rate. If we want to figure out how many gallons the car would need on a 420-mile trip, we could think of fuel use in terms of the rate of use per mile, gallons per mile. We said the car gets 16 miles per gallon, the mileage rate. If it's 16 miles per gallon, it must be 1/16 gallons for each mile. It's the inverse of miles per gallon, but it's still a rate. To figure out how many gallons we will use on a 420-mile trip, we can multiply the rate of 1/16 gallons per mile by the number of miles, 420. That's 26.25 gallons for the whole trip. A rate is a change in any quantity with a change in another, as long as they change together. No matter the quantities, considering rates can be a useful tool for figuring out total amounts.